Space, the final frontier, the source of all questions and all answers. The genesis of humanity's greatest mysteries. What came before the Big Bang? If the universe is infinite, how come there's no evidence of extraterrestrial life? Has humanity passed the Great Filter? Or have we yet to reach it? If dark matter doesn't affect us physically, wouldn't "doesn't matter" be a better name? Perhaps, in order to begin answering these questions, we must start looking closer to home. What secrets does our neighbor Venus hold? We're working on finding that out. At the University of Cincinnati, our senior design team, LODESTAR-V, has designed a proposed space mission to fly 4 astronauts into and out of Venus's orbit in the early 2030s. The mission will be a great stepping stone in interplanetary travel and will demonstrate capabilities for missions to come. Furthermore, the mission is a great opportunity to study the planet in detail. If it seems like a difficult mission, don't worry, we made sure to plan it out.
Hi, my name is Jazz Rosen. I am the Systems Engineering Lead of LODESTAR-V, and I am joined by 12 other teammates: Evan Burwinkle, Henry Mathis, Henry Voss, Jake Gerbach, James Fauna, Jared Smith, Joe Baker, Caden Wells, Matthew Franzek, Nathan Passarge, Martin Hulp, and Walton Stone. We are the AEM Spacecraft Senior Design Team of 2020 and 2021, and we are very excited to present LODESTAR-V, a multi-modular space station concept designed to sustain a crew of 4 intended to perform a flyby of Venus. LODESTAR-V stands for Long Duration Expedition for Science, Technology, and Research of Venus. We thought this name was quite fitting, as a lodestar is a star that is used to guide the course of a ship, or something that serves as inspiration. This mission, and the technologies required to make it happen, would serve as a monumental stepping stone to manned interplanetary travel. The project management style of LODESTAR-V seeks to mirror notable space programs such as NASA. Our team was split into 9 subsystems, all headed by an executive board. The LODESTAR-V mission concept is designed to address the key concerns of Theme 3 of the 2021 Rascal competition, a student design competition sponsored by NASA and the NIA. For this theme, NASA is interested in a crewed flyby mission to Venus in the early 2030s. This mission seeks to allow for a close observation of our closest planetary neighbor, Venus, as well as build experience for future long-duration deep space missions to Mars. There are 3 main objectives that have been derived from Theme 3. First, what scientific research of Venus are we aiming for? Second, demonstrate the feasibility of a long-duration manned space travel. And lastly, identify any commercial capabilities and developing technologies that LODESTAR-V may take advantage of.
Hello, this is Caden Wells. I'm a member of the Structures and Propulsion subsystem team, and here we have the LODESTAR-V module layout for the entire spacecraft. In the back half, we have the engine and the power and propulsion module. This has the fuel tanks, the thrusters, and the solar arrays. And towards the front half of the spacecraft, we have the habitable volume. This comes to be the airlock, the primary crew quarters, the storage module, and the control module. The total habitable volume comes out to be a little over 257 meters cubed. The total dry mass of the craft is 112,000 kilograms, and the total wet mass is just above 600,000 kilograms. Here we can see the comparison of the entire LODESTAR-V spacecraft with the SpaceX Starship. Just a little bit smaller lengthwise, and it's much wider.
The mission begins on Earth, where the modules will be fabricated and prepared to launch. The modules and supplies will be sent to lunar orbit on 15 different launch vehicles and assembled at the Lunar Gateway. After assembly is complete, a final crew vehicle will bring the crew of 4 to LODESTAR-V. Once the crew is ready, LODESTAR-V will detach from the gateway and begin transit to Venus and preparing for the flyby. During the flyby, 3 science payloads will be deployed to collect scientific data of Venus. Next, LODESTAR-V will then return to lunar orbit and dock with the gateway, allowing the crew to re-enter the crew vehicle. The crew will then return to Earth via standard re-entry procedures. With our current estimates, we predict that our mission will last approximately 11 months, leaving during February 2033 and returning around January 2034. Following the departure, LODESTAR-V will perform an 80-day transfer to Venus, and after the flyby, it will perform a 256-day transfer back to lunar orbit. The LODESTAR-V program timeline will take roughly 11.5 years from the approval of the MCR, or Mission Concept Review, to the eventual return of the crew to Earth. LODESTAR-V, as well as the science payloads, will go through phases of concept and technology development, DDT&E, or Design, Development, Testing, and Evaluation, fabrication, and system integration and testing. 16 launches, which includes the crew ascent vehicle, will occur during September of 2030 through October 2032. Then, the LODESTAR-V mission will begin during February of 2033, as well as the mission and ground operations and mission logistics.
For the propulsion system of the craft, a multi-mode propulsion system was chosen. This is the case because of the theoretical benefits and flexibility it would allow the mission. A multi-mode propulsion system consists of a chemical and electron ion propulsion mode, both utilizing the same fuel and the same machinery. Basically, if you want to have high delta V in a little bit of time, but at the cost of efficiency, you use the chemical propulsion mode. And if you want a high delta V during lots of time, but with high efficiency, you use the ionic propulsion mode. The multi-mode propulsion system can switch between both modes depending on the mission parameters and depending on what section we are in the mission. The high efficiency of the electric ion and the high delta V of the chemical propulsion allows the mission flexibility and can save total fuel mass. The question is, how much mass? By creating a code that simulated the journey from Earth to Venus, we were able to estimate an early optimization loop that can find the total amount of mass the multi-mode propulsion system could save compared to a total chemical propulsion system. By doing this, we were able to show that the multi-mode propulsion system could save roughly 140,000 kilograms of mass compared to a purely chemical propulsive system. And this gave us confidence to choose the multi-mode propulsion system for LODESTAR-V.
Hello, my name is Henry Voss, and I am the president of the CEAS capstone group. I am also the team lead of the payload subsystem. For the LODESTAR-V, the crew systems team decided to utilize multiple robust life support systems to support a crew of 4. The ECLS-S is a robust life support system that was used on the ISS and is being upgraded by NASA. It is able to recycle 90% of water and 75% of oxygen. OSCAR is a waste management system that will reduce the volume of generated solid waste and to convert waste products into useful gases. It is able to convert about 90% of solid waste to gas. LODESTAR-V is taking advantage of some of the following emerging technologies. ROSA, which is vetted by NASA to be used on the ISS and Lunar Gateway. It offers high modularity and full autonomous deployment. It offers maximum power output of 220 kilowatts on LODESTAR-V. DSOC is a communications technology that uses lasers to talk to ground station telescopes. It has about 10 to 100 times the performance of current telecommunication systems.
To determine the science objectives for the Venus flyby, the payload team analyzed a couple of meta-analyses on the knowledge and potential questions that still need to be answered. We identified 3 major categories of needed study for Venus. First, geology. Second, atmosphere. And third, geochemistry. And then listed various questions in those categories. With this information, we ranked 5 different types of payloads by how optimal they were for answering that particular question. As you will see in the next slide, we chose 3 payloads: an orbiter, an air balloon, and a surface lander.
For the payload team, they researched meta-analyses of Venus to determine science objectives for the LODESTAR-V mission. The team determined 3 different payload vehicles to send to Venus. The orbiter will be sent to investigate atmospheric formation and climate. The air balloon will investigate geochemistry, the magnetic field, and the ionosphere. The surface lander will investigate geology on the surface of Venus. Thank you for watching this video. It is very hard to condense this mission concept into a short 10-minute video, and we still have so much to share. Please feel free to talk to us and ask questions. We will be happy to answer.